This is Chapter 721's Animatronics project. Our project is an ecosystem exhibit that could be on display at a science center. It highlights and explains several important abiotic and biotic factors of an ecosystem, as well as key ecosystem processes. This is a flowchart of how our project works. To start, the user says, "Alexa, trigger ecosystem exhibit." We programmed Alexa so that when this specific phrase is said, it performs two main tasks. First, it begins playing nature sounds through the speaker. Secondly, Alexa sends a trigger to another software called IFTTT. When IFTTT receives the trigger, it calls a code function within our Photon microcontroller, which is connected to the internet. Here is the code for the Photon. These first lines of code declare and set the initial values of the variables used in the code, as well as declare which pins are inputs and which pins are outputs. This part of the program constantly loops as the microcontroller is on. And this is the method that is called by IFTTT. When the method is called, a value of start is passed through the string command variable. When command equals start, the variable go is set to true. Now if we go back up here, we see that while go equals true, all of these lines of code execute. The use of the function ensures that these lines of code only execute after someone says, "Alexa, trigger ecosystem exhibit." These first two lines set the values of our output pins to high, which makes them output electricity. These other lines cause our blue servo motor to turn 90 degrees and hit a limit switch to start our fluid power circuits. Alexa, trigger ecosystem exhibit. Once this limit switch is hit, it starts both of our pneumatic fluid power circuits. This is the ladder diagram of our first circuit. Our first circuit uses control relays, a DCV, limit switches, and a pneumatic cylinder to create a reciprocation circuit. This circuit causes the cylinder to extend and retract, which controls the movement of our fish's tail through the use of our cabling system. Our second circuit controls the movement of the turtle. This is the ladder diagram for our second circuit. Our second circuit, to move the turtle up and down, is also a reciprocation circuit. This circuit uses a dummy cylinder to control the movement of a smaller cylinder, which causes the turtle to move up and down. We decided to use a dummy cylinder so that we would not have to mount limit switches on top where the turtle is located. The Photon also sends electrical signals to two other microcontrollers. If we go back to the Photon code, we remember that these two lines of code cause output pins on the Photon to output electricity. These pins are connected with wires to input pins on the other microcontrollers. This first microcontroller is responsible for the movement of the bear. This is the code that's used to control the servo that controls the bear. Like the other program, these first lines of code are used to initialize and declare the initial values of the variables used in the program. These lines constantly loop while the microcontroller is on. This first line is very important. It reads the value from the input pin, which is connected to the output pin of the photon. If this value is greater than a specific value, meaning electricity is present, then these lines of code will execute and cause the servo to move. Alexa, trigger ecosystem exhibit. The bear moves through the use of an interior skeleton, which is attached to the servo motor. The photon also sends an electrical signal to another Arduino microcontroller, which is used to control the lights. This is the code that's used with the microcontroller that controls the lights. This program also waits for an input from the photon. When this input is received, all of these lines of code begin executing. These lines of code control the lights and turn them on and off in a wave-like pattern. Here's our lights working and lighting up the underwater portion of our project. Next is a clip of our project working all together. Alexa, trigger ecosystem exhibit.